Hello and welcome to Chemspec Digital 2021. I have the pleasure to introduce the next presentation in the Reach Lecture Theatre. Before I do that, please note we're recording this session to have it available for on-demand viewing afterwards. And could I invite the audience, should you have any questions, please can you pop those questions into the chat function, which you'll find in the top right-hand side of your screen, so we can have those questions ready and waiting for the Q&A session that will be after the presentation. So now I can introduce our speakers. So can introduce Martin Willis and Giuseppe Fororello from IPI Global, who will be presenting how closed chemical systems help achieve circular economy goals. Over to you, Martin.
Thank you very much, Jason, and thank you to the organisers. It's good to be here, if not in person, to be here virtually. To have this opportunity, and we're very much looking forward to the show next year in Frankfurt, to be able to talk again and meet customers in person. I think that's overdue and something the whole industry is very much looking forward to. So my name is Martin Willis, and I'm going to talk about closed returnable chemical systems and how they can help achieve circular economy goals. This presentation has been authored by my colleague who's with me, Giuseppe Fiorello, and covers quite a bit of ground on how closed chemical systems work, various regulations, the international framework. So without further ado, I will get started. Now, we know that people are talking about the circular economy and circular economy principles. The last shows that we went to, apart from the Chem UK last week, were in Dusseldorf in 2019. And this is something that was a very hot topic. We know that it's related to Kunststoff or plastic, but nevertheless, it was still something that the plastics industry was talking a lot about. And we see the graphic there, which represents what the circular economy is, and pictures of various initiatives that companies at that exhibition took. So before we do that and look in detail, it's important to get some background. We know that plastic in circulation needs to be reduced. That goes without saying. Even the plastics industry are saying exactly that. It's with supermarket packaging, with drinks packaging, but also with industrial packaging. Reuse is very important. And by the time we get to 2050, we will be consuming as if we had 3 Earths. So there's going to be a big increase in consumption as population increases. I'm sure we're familiar with what biodiversity is. And the vast majority of the loss of biodiversity comes from resource extraction. So taking the goods we need, taking the plastic from the ground. Waste will increase significantly, up to 70% by 2050. We can see on the right-hand side there what we're already seeing in some supermarkets, but need to see a lot more of, which is reuse of packaging in supermarkets. So taking your packaging for cornflakes, for pasta, for all sorts of day-to-day goods and reusing it. We're seeing it in supermarkets. We need to see a lot more, and we certainly need to see a lot more of it in the industrial environment. To address this, there are various legal frameworks in the EU and internationally. So we have the UN Convention on Climate Change, otherwise known as the Paris Accord from 2015. That was something that had not been signed up to by America. With the election of Biden, it is now something that is signed up to again. So another major player within that. And the EU equivalent is the EU Directive of 2018-852. Its aim is to close the loop on product life cycles and to extract maximum value from all raw materials, product and waste, and prevent undue wastage. So the UN background. The UN has developed a series of sustainable development goals. 193 states are involved, and there are 17 goals. On the left-hand side, you can see each of the goals and various icons that they've produced for them, but they are chiefly to combat and address global warming, optimum use of natural resources, to reduce climate change and environmental impact, to improve water quality, and for economic and urban development, to influence how that develops. The EU circular economy is very, very similar. The EU Commission has adopted an ambitious circular economy drive in parallel with this. The idea to close the loop of product life cycles, greater recycling and reuse, to extract the maximum value from raw materials and natural resources, saving energy and reducing greenhouse gases, and to benefit the environment and the economy. A little bit more detail on that and how it works is the EU Green Deal. The EU Commission has launched the Green Deal to target no net emissions of greenhouse gases by 2050, to decouple economic growth from resource use, leaving no one behind. The action plan to achieve it is to boost efficient use of resources, to aim for a clean circular economy, to restore biodiversity, and to cut pollution. We have references for all these, for everything that we're talking about here. If you want to know a little bit more or do a little bit more further reading on this, please let us know in the chat, in the questions, and we can provide you with the background material. This is a summary of it. So we've talked about UN Sustainable Development Goals and the EU Green Deal. It's important to say that the chemicals industry, our industry, is a very important part of this. It's not neglected in any way. So we know chemical pollution can amplify climate change. It contributes to the degradation of ecosystems and the loss of biodiversity. So the UN target is to achieve sound management of chemicals and wastes and significantly reduce their release. I'll just leave you to read that because it summarizes what they're trying to achieve. And this is from the UN Conventions on Chemicals and Waste, the Basel Convention, and the Rotterdam and Stockholm Conventions. What we've also seen very recently in what we do here is a major push in the agrochemicals industry to adopt this for herbicides, for pesticides, and for agrochemicals in general, also in seed treatments. So what are the implications for the chemical market? The part that of this initiative within the EU Green Deal that refers to chemicals is the EU 9462 EU or 2018-852 about chemical packaging. So by 2030, 70%, a minimum of 70% of packaging waste needs to be recycled. That's for everything, but it includes chemical packaging. By 2050, there is a carbon neutral target for plastics. And there are two main areas to talk about when we talk about the circular economy. There is reuse and recycling. So reuse is the ideal situation. You reuse everything for the same purpose. You never have to produce or extract anything else. That's the nirvana, the ideal situation. But of course, recycling is also a part of this. You reprocess waste, not necessarily for the same purpose, but you recycle what you've already got. So for this reason, collection and reuse needs to take into account two things: health, safety, and hygiene, and potential contamination. So if you're using something that's been in use for a chemical, for example, you wouldn't then want to use it or reuse it or recycle it for water or food or anything like that. So it's important to take into consideration when you're doing this. So how can closed transfer systems help? Now, when we talk about a closed chemical transfer system, you can see on the right a video demonstrating what that is and how it works. A valve is attached to a container, which allows the liquid to be taken out of the container. And while you're doing that, you're protecting the outside world, the workers, and the environment from exposure to that chemical. But it also means you can reuse that container multiple times. So how do closed seal containers and closed loop dry break systems help? They stop material contamination throughout the pack life. So there's no external or internal contamination inside the container and no escape of chemicals to the outside world. So the outside world is protected, but also the integrity of the chemical inside is protected. What does this mean? Less water, solvents, materials, or energy is then required to clean PPE, plastics, the equipment, water tables. You don't get the chemical escaping into the water table. So with the integrity of that chemical and the way it's preserved, no escape to the outside world, you cut down a great deal on cleaning. There's no escape of water tables. It's just a closed, sealed container throughout its life cycle. Because the use of water to clean is something that's very significant, and we need to cut down on very significantly. And then closed loop transfer within the circular economy. So how do closed sealed systems and closed dry break systems help? They prevent the escape of vapors and drops. Hydrazine is an example where the amount, we'll see in a moment a video study on that, the amount of hydrazine in the atmosphere is kept below 0.02 parts per million, so well in line with EU circular economy goals and protection of workers in the environment. In IBCs with a closed loop system, they are reusable for the whole of the container's lifetime in a cycle of fill, ship, return, refill, fill, ship. So the closed system enables to extend the life of the IBC or the container, which we'll see in a moment. It reduces the number of containers, reduces energy, water, and consumption, which is critical. And of course, you have a stainless steel IBC container option as well for ultimate lifetime. On the right-hand side, you can see how the liquid is transferred from container to container on the right-hand side. And then also the vapor is contained or recovered back into the container. So there's a two-way process, the liquid into one container, which pushes the vapor back into the original container. So it's a completely sealed system. I'm now going to show you a video which shows this in action. It's all very well saying, okay, how does this work in principle? But this is a company, Okema, who have used the closed system within an IBC so that containers can be reused as long as the lifetime of the container can take it. I'll just play the video. It's about 3 minutes, and then I will pause at various points to explain it. The initial part of the video shows the filling of the container at the customer's site. In this case, it's with hydrazine hydrate to go to a power station. So a little bit of scene setting there. So you can see various types of containers are filled from, that's a 25 litre can, up to a 200 litre, which you'll see in a moment, and an IBC, which you will also see. Totally secure filling.
It's been invaluable. It allows us to transfer carcinogenic chemicals safely at our facility with no exposure for operators, and also our customers can dispense products safely too with no exposure. We fill it through the valve here at Lansdowne. Our customers dispense through the same valve too. There's no exposure from the valve itself because everything's a closed system. It's a lot more robust because it's made of stainless steel, and it's provided us a high degree of integrity. It's been a real game changer for Lansdowne Chemicals.
Oh, sorry, moved on there. I shall go back to where I was. So what you've seen so far is the filling of the containers. Then you see the transport. In this case, they are taken to a power station where the hydrazine hydrate is used within the water supply within the power station to stop rusting and oxidation of the pipes. So here the container is taken in the power station and is emptied, again in a secure, safe manner to prevent exposure to the operator and the outside world. And the various containers are emptied. And that's the principle. You can see there is a down tube that goes to the bottom of the container, and the container is emptied by pump. This is a subject of a study by the UK HSE, and it also complies with EU 2004-37 EC for carcinogens. And the 8939 EEC regulation. So that's a nice summary of how it is used in action by companies for protection of workers and the environment and to achieve circular economy goals. It's all very well saying that. Companies will do that, they will protect their workers, the environment, but is there a financial aspect to this? Well, yes, there is. There is a benefit of following these principles. Protecting our planet and futures is obviously very important, huge reduction in cleaning resources, but it has been shown that companies that invest in this kind of technology, it actually creates jobs and opportunities, and companies will benefit commercially from it. The estimated benefit is 1.8 trillion by 2030. That's a reduction in the net spend, according to EU estimates. So it is worth doing and worth looking at further. So that's the end of the presentation. Thank you very much for your attention. And I would like to open up to any questions. Or back to Jason.
Thank you, Martin. Much appreciated for that insightful presentation. A lot going on there. All right, so brought us to the quick Q&A section of our session. So as mentioned previously, audience, if you could pop your questions into the top right-hand corner, there's a chat function, which will allow the questions to be brought through to us so we can pose them to Martin and Giuseppe. So if you could do that, we'd appreciate it. There we go. We have a question that's come through. Martin, I think this one can go to you.
Yes, Jason, hi.
How many times can the plastic IBC be reused when fitted with the metal closed system valves?
The IBC that you saw in that video, it's basically used through the life cycle of the container. So you have a lot of containers that are sent out, for instance, with hydrazine. I know some containers are sent out single use, so they're sent straight to the end customer, and then they're scrapped, they're not used anymore. If you include the closed system, it can be used. Well, talking to my colleague here who has an idea.
Yeah, usually depending on also the quality of the IBC, but generally in this case for what is the experience of Okima is 3-4 times, even more, depending on the quality of the IBC. Think about that the system, the valve is stainless steel, so the span life of the stainless steel is around 20-25 years. What can be changed time by time is just the seal materials. That's it.
Mm-hmm.
Okay.
Yeah,
Thank
so
you.
it greatly extends the life window. We've seen 18 months, haven't we, used as a figure for the IBC. So as long as the IBC can stand it, until the IBC is not used anymore, it can withstand it.
Okay, thank you for that. I think that was pretty clear, I think. We have another question that's come through. This question is, shall I give it to you, Martin? Would you like to take it?
Yeah, sure.
Okay.
First instance, if I can't answer it, I'll always refer it on.
Very cool. If the vapor recovery system is not fitted, what is the arrangement for returning the air back to the container?
Okay, so yeah, I mean, you have the, I can share the screen again. Shall I share the screen again and you can see what we're talking about? Can you see that okay?
Yeah, we see it.
I'll just go back to the relevant one. So, oh, sorry, I'm having a bit of trouble getting to the right one. What we saw was the liquid went in one direction, and the vapor recovery went in the other direction. There we go. I'm moving this to the right place. So if you can see the slide on the right-hand side where it says typical vapor recovery system using vapor recovery coupler.
Yes.
You can see that.
Yeah.
So I think what the question is referring to is if this isn't fitted. So here's your vapor recovery line, and that takes the vapor back into the container. So the liquid goes one way and this goes the other way. Sometimes this isn't fitted, this vapor recovery line. What then happens is, as this container is being emptied here, you have a system whereby there is a vent or a self-venting coupler, which brings the air from the outside world back into the container. So it is a one-way system. It's not going to go, the fumes aren't going to go back out. But as the liquid comes out of this container here, obviously that's going to produce space, and the air will be sucked in effectively through the vapor recovery coupler there on the outside. So if this is not fitted, it just brings the outside air in.
Yeah, moreover, just to complete, give an extra information, where the air inlet can be also attached to the nitrogen, for example. Mm-hmm. In this case, you can have an inert atmosphere that reduces drastically, especially when you have flammable liquids, that the liquids can be inflated. So you can also attach to the nitrogen and create a blanket of nitrogen inside the container.
Mhm. Yeah, indeed.
Thank
Another
you.
way of doing it. So yeah, it is covered. There's no escape of fumes, but the air comes in from the outside or the nitrogen blanket.
Okay, I think that answered the question. That also brings us nicely onto time. So we've now come to the end of the Q&A session. So I would like to thank Martin and Giuseppe for their time and for their very insightful and thoughtful presentation. I'd like to thank the audience for attending as well. That was much appreciated. I'm sure the audience can reach out to you if they have any questions, if that's possible. And on that note, I would like to say thank you to everybody and have a lovely day. Thank you.
Okay. Thank you very much.
Thank you. Cheers.